Okay, so this is a bit of an extension video, so for those of you looking for a little bit of an extra challenge, we're going to look at the number e, which is also referred to as the natural exponential. This is because it arises naturally in both in math and physics, the physical sciences in general, the same way that pi arises naturally in geometry based on the circumference of a circle. So this number was discovered by Euler, hence the letter E, and it is an irrational number, just like pi is. So remember, pi, it doesn't end. That decimal goes on forever and ever and ever, and we can't write it as a fraction. Yeah, we can write it as a fraction that gets very close to estimating the value of it, but it's not the actual value of it. And E is similar. It's a decimal that goes on forever. It doesn't repeat, and there's just no way we can write it as a fraction. So it's an irrational number. So we're going to look at calculating E. This is the definition of E, and it's actually, as you learn about calculus, this is the limit as a goes to infinity of this expression here. Okay, what that means is, you will learn about limits in the future, but basically to simplify that, it's as we make a larger and larger number, so as a gets closer and closer to infinity. So this value here and this value here, as that number gets bigger and bigger and bigger, we are going to get the number E by calculating that expression. And I've started to do that on the calculator to the left here. I don't want to waste time in the video punching in these buttons, but okay, so if we make A 10, you can see that right here. We've got 1 plus 1 over 10 instead of A, and then to the power of 10, we get 2.59374. Okay, and if we make A 100, so we've got 1 plus 1 over 100 to the power of 100, we get 2.70481. Okay, and if we keep making A bigger, if we make A 1,000, we have 1 plus 1,000, 1 plus 1 over 1,000 to the power of 1,000, and that gives us 2.71692. Okay, if we make it 10,000, we're going to get 2.71815. Okay, and if we make it 100,000, it'll be even closer to E. So the bigger that number A is, the closer and closer we get to the value of E. So this is 2.71827. Okay, so you may have heard people estimate the number E before, and we use the estimation of about 2.718. Okay, but remember that's not what E actually equals. E is actually a number that continues on and on forever and ever because it's irrational. So it's 2.718, and you can see it here. And remember, this goes on infinitely. It does not end. But we can use this estimation to kind of work with that number. And you can get E on your calculator by doing just doing E to the power of 1. And it'll give you an estimate of that depending on your mode that your calculator is set on. Okay, so this is the number E. We're going to go through some examples and look at where this number comes from. How does it arise naturally? To do that, we're going to need to look at compound interest. These are just two different ways of presenting the same formula. So compound interest, we can take our present value and multiply it by 1 plus the interest rate as a decimal and take it to the number of periods that our interest is compounding over. Okay, another way to look at it, and more specifically, this is what we're going to use for the following examples, is the principal, which is what you start with, times 1 plus the fraction of rate as a decimal, again, divided by the number of times per year the interest is compounded, which is n. And then that's all to the power of n, the number of times it's compounded, times t, the time in years. Okay, and then that's what we get, how we get our amount. So I'll write that again. That our amount is equal to the principal times 1 plus r over n to the nt. Okay. So suppose you need a loan. You go see, this is just kind of a joke, but you go see a loan shark. You go see someone that can give you a loan. You don't need a big loan, you just need 1 Swiss franc. So your loan shark says, okay, I'm happy to give you that loan, but I'm going to give it to you at 100% interest rate for the year. So you're going to pay that off at the end of the year. So how much would you owe at the end of that year's time? So originally you owe 1 franc, and then you owe 100% of that, on 100% of interest on that. So our rate is actually 100%. Okay, and that's after 1 year. So, sorry, our principal is 1. Okay, so again, we've got our principal. This is what we were starting with. We owe 1 franc. We always need a 1 here. This is just part of the formula that keeps it at 100%. Okay, plus our interest rate, which you said is 100%. You have to pay 100% of your loan back at the end of the year. So you have to pay the 1 franc that you borrowed back, plus if we add 1 plus 1, that's going to give us a total of 2 francs. So if you think about it, we have to pay our 1 franc back at the end of the year, plus another 100% of that. So that's 2 whole francs that we'll have to pay back at the end of the year. You say to the loan shark, hey, I think I'm able to pay off this loan halfway through the year. I think I only need 6 months to do this. And he says, yeah, no problem. But if you can't pay it off in 6 months, that interest is going to compound, and you'll have to pay interest on what you couldn't pay off for your loan. So he's saying, yeah, the interest rate is still 100%. You've still got a loan of 1, but we're going to give you 2 chances to pay that off this year, and maybe you'll be able to pay it off within the first 6 months. So this is the number of times it's going to compound. We'll have 2 times 1, again this is n, and this is for 1 year. This is our time. Okay, and 1, our rate is still 100%. We didn't change the rate. Okay, so we're gonna plug that into our calculator. We'll get 1 times 1 plus a half, and this is to the power of 2. Oh. And that gives us 2.25. Okay, so notice how that compares to if we just had 100% rate. We're actually going to have to pay more. So if we can't pay it off in this first 6 months, we're going to have to pay more because we're paying interest on our interest, basically. So it's going to be even more expensive if we don't pay it off in the first 6 months, if we're going for an interest rate half the year, basically. So every 6 months it's going to compound. So if we can't pay it off in a full year, we owe 2.25 francs compared to the 2 francs. Okay, so what if, of course, we say, you know what, I can pay this off ideally in the first month. But we also have to look at, if we're not able to pay it off in the first month, the loan shark tells us it's going to compound. That interest is going to make interest on its interest, and we're going to owe money on that as well. So let's look at what this is going to give us. We've got our 1 Swiss franc loan. We've got 1 plus our interest rate, which was 100%, it's going to compound 12 times in a year because there's 12 months in a year, and we have 12 times 1 because we're talking about 1 year. Okay, so if we do that in the calculator, we've got 1 times 1 plus 1/12 to the power of 12. And that gives us 2.61304. Gotcha. So it's even more, isn't it? Look, we've got with paying off our interest, if we were to try to pay it off halfway through the year but then couldn't, we would owe 2.25. And if we were to try and pay it off every month but couldn't, even by the end of the year, we'd owe 2.613 francs. So okay, so let's look at this daily and hourly. So daily, we've got our 1 franc. We've got 1 plus our interest rate divided by the number of days in a year. We'll say it's not leap year. And 365 times 1 year. Okay, so if we calculate that, 1 times 1 plus 1 over 365 to the 365. Oh. We get 2.71457. Okay, hourly. So we know there's 365 days in a year. We know there's 24 hours in a day. That can give us the number of hours in a year. So 365 times 24. We get 8,760 hours in a year. Okay, so if we ask them, hey, can I pay it off every hour? We'll have our 1 franc times 1 plus our interest rate of 100% over 8,760. That's the number of chances we get to pay off this loan, because that's the number of hours in a year. And that number again times 1 year. And if we calculate that, and we get 2.71813. Okay, so hopefully you picked up on the pattern. If we don't pay off our loan, right away, it's going to just continue to compound, and we're going to earn interest on our interest. And do you see this number is going to, over time, go towards the number E. And that's kind of how it arises naturally. That's one way in mathematics. So you can see if we take the limit as x goes to infinity, or in other words, if we continue that, if we compound it every second, if we compound it every millisecond, so we're making this number larger, the number of times per year that we're given the opportunity to pay it off. And if we still can't pay it off by the end of the year, the amount that we owe is going to go very, very, very close to E. And the closer that number x, this value, is to infinity, so the larger that number is, the closer the amount that we owe is going to be to the number E. Okay. So we just talked about that. This is an extension of that. This is called interest compounding continuously. So to get that, we take the principal, which in our case was 1 franc. We'll take E to the power of our rate, which was 100%, remember, times our year, our number of years, which is for us 1 year. So this is called compounding interest continuously. So you use this formula only in that case if your interest is compounding continuously, and the reason you do so is because of the calculations that we've just done. And if that were to happen in our example, we would get the number E. So if the loan shark gives us the opportunity to compound our interest continuously, that means even more often than every second. It means continuously, every split second, every millisecond, even faster than that. So the most we will ever have to then pay for our loan of that same interest rate is going to be the number E, so about 2.718. Okay, that's it. Thank you, guys.